Alright, so phase shifts and vertical shifts. So when you add stuff on the insides, basically what I was trying to tell you guys here a moment ago is that would be when you shift a graph from the left to the left or to the right. It has a fancy name for some reason here. It's called a phase shift. Okay, and we'll just look at an example. So let's say I had the function y equals sine of x minus pi over 2. Okay. Let's assume that you didn't do anything. What would be the first value that usually we've been plugging in for our x's so far? We've always started every table at 0. Okay, and it's a regular sign, so this is the normal progression of the table, right? 0, pi over 2, then it would be pi, and then it would be 3 pi over 2, and then it would be 2 pi. Yeah? Okay. Well, what happens if I do this on x minus pi over 2? When you plug in 0, okay, so if I plug in 0, and don't put it in this table, I'm going to erase this here in a second. If I plugged in 0, what would be 0 minus pi over 2?
Negative pi over 2.
And I have no idea what the sign of a negative pi over 2 is worth. I know what it's worth at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so I don't want to do this in the table. I want to sort of set this table up so I don't have to do additional math in here. What I'm shooting for is the following pattern. This pattern is what needs to be the same in every single table that you use for signs. And that would be the pattern for the sign, which starts at 0, goes up to
1, 0, negative 1, 0.
Okay, so what we're going to do is we're going to adjust these values here. So this is where you're going to see your shift. We're going to shift those x values so that it basically works like as if it said 0, 0, pi over 2, 1, 0, negative 1, and 0. Are you guys sort of okay with the idea here, what we're trying to do, which now I need to go do it, but are we okay with sort of what I'm hoping to accomplish here? Okay, so what I'm hoping to accomplish here can be done by solving this inequality. Okay, so if I solve this inequality, and all this is on the inside is the same thing that I have here, right? Yes? See how I just took the x minus pi over 2 and I literally just stuck it in that inequality? So I want to solve that. And you can do this like one at a time. So what do you need to do to get rid of the negative pi over 2?
Add pi over 2.
So it's trying to tell me I should start my table at,
Pi over 2.
okay, start the table at pi over 2. Okay, on this side it should say less than or equal to 2 pi, right? If I add pi over 2 to that, what do you get here? And this is where the fractions sort of get in the way sometimes. So what's 2 pi plus pi over 2? 2 pi would be 4 pi over 2, right? So 4 pi over 2 plus 1 pi over 2 is? Anybody? What's 4 pi over 2 plus pi over 2? What's 4 over 2 plus 1 over 2?
Pi over 2.
So 4 pi over 2 plus 1 pi over 2 is?
5 pi over 2.
5 pi over 2. So 5 pi over 2. That is the end on that shift. Okay, so the shift comes from finding a new starting and a new ending point. Okay, how do you find the period, Cam, usually? Right in front of the x, right, which is still a? Okay, and the nice thing for you guys is I think every single problem that we're doing and that we will do, the period is, I'm not changing both the period and having a phase shift. That would be for like the next class. So, but I did want to show you that the period here is still 2 pi divided by 1, which is? 2 pi, right? What do you need to multiply by to find your count bys? So we're still counting by pi over 2's, right? Yes? already have a starting and an ending point, so that means if I start at pi over 2 and I keep adding pi over 2's, I better end up at 5 pi over 2 with this amount of steps. So pi over 2 plus pi over 2 is? Which is just? And then 2 pi over 2 plus another one is? And the next one is 4 pi over 2, which is? 2 pi, and then the next one would be 5 pi over 2. So do you guys sort of see that it works? Okay? This line here, you can sort of ignore. I have it in there because I just want to show you what happens here, and this is the whole reason behind doing this. So if I use pi over 2 as my first number, what do you get when you do pi over 2 minus pi over 2? Yeah, and pi minus pi over 2 is? Pi over 2, right?
Yeah.
And then 3 pi over 2 minus 1 pi over 2 is 2 pi, which is pi. This ends up being 3 pi over 2, and this ends up being 2 pi. Do you guys notice that this is what we've been seeing so far? This is the line that I said that I wanted to have in my table. Okay? Now that line, I don't think you need to show me this in your table, so I'm going to cross it out. And I know this is really messy, but we'll do another one here in just a little bit. Okay, I'm going to cross it out because if I set up my count bys and my start and my end right, that is what I end up with, right? So the whole reason that I do all this work here, so this shift that I did over here, so this shifting business, and then the period and the count bys, that allows me to set up this top line so that I end up with 0, 1, 0, negative 1, and 0. Just like I'm supposed to. Okay? Alright, I guess we need to graph it, so I'm going to squeeze the graph in over here, which shouldn't be too bad, because it only goes up to 1 and down to negative 1, right? Alright, so here's pi over 2. Then 1, 2, 3, 4 steps, that means I end up at? And at pi over 2 I should be at? 0, 1, 0, negative 1, 0. Normal pattern for your sign. That's what it looks like. Okay. I would be perfectly happy with this one. What are we counting by exactly? Pi over 2. So the next one would be here, right? And this value is sort of the next in the pattern, isn't it? So I'm just going to extend this pattern based on what I know. Now you don't have to do that. So if you're not sure, don't do that. You could just leave it for one period as long as it's spaced right and your table is right. I don't really care if you extend it or not, but I have to show this because that's what the book does. So okay? Let's look at another one. Sorry, we're going to look at the other one. So the one that you guys get this confused with a lot is the one on the outside. So what happens when you put the 2 on the outside? Yeah, and we've seen a couple of those, right? So I should be able to do this maybe a little bit faster. So Connor, do you remember how to find a period? I'm going to take 2 pi and divide it by, well, 1, but in this case it's a 4. Okay, so this does change the period, right? Because that's actually pi over 2 already. So I'm going to start at 0 and go to pi over 2. You figure out your count bys by multiplying by 1 over 4, so we end up counting by pi over 8. So 0 plus pi over 8 is 1 pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, which is not reduced, and 4 pi over 8. 4 pi over 8, is that pi over 2?
Yeah.
Good, then it worked, right?
Yeah.
The normal pattern for the sign again is?
0, 1, 0, 0.
And then you guys already told me that 2 does just what to all this mess?
Moves it up.
Yeah. So that is a transformation that you do literally in your table, whereas the other one the first one I had to set up the table for it, right?
Should that be sine on, is this 2 plus sine 3x?
It should be 4x. You're right. I used to do it with a 3x, but the period got to be so ugly that I quit doing it. Now you should be able to do it with a 3x, but in terms of explaining it, it just works nicer with an even number. Okay. So this graph, hopefully you're comfortable with, and most of you guys are comfortable with this one. So 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. It actually starts at 2, and it goes up to 3. So at 0 you're at 2, 3, 2, 1, and 0. The spacing is a little bit off. Wow, that was really ugly. I have to do that one again. I was doing alright to here. Okay. Alright. We're good. Can I move on? So let's do one where, so this would be about as complicated as I will give you. Okay, so what I will not do is we're not going to do a change in period and a phase shift. But otherwise than that, there could be 3 transformations that you would have to do in one problem. So I could change the period, I could change how far, or like how high or how low it goes, and I can shift it up and down at the same time. So that would be 3. And so like in this one, there is a phase shift. So how do I know that it has a phase shift? Well, there's an addition or a subtraction on the inside. So here's your first transformation. So there's a phase shift. That's this part. Okay? So that's the first one. The multiplying here, which was pretty easy for most of you guys, it's called the change in amplitude. That's just the multiplication kind of thing. So this is the amplitude change. And then the negative one is a shift. And in this case, are we shifting up or down? So we're going to shift down. So there are 3 things I need to account for in this particular problem. Okay. The first thing you need to do, if there is a phase shift, you always have to find your phase shift. Okay. So just copy this thing. Where do we like our sign to start? The first x that we would like to use is always
0.
And we'd like to end it at?
0.
No, you're thinking about the pattern. The first x is 0, and I want it to end at 2 pi, right? Keep in mind that this is a change in your x values. So, and I didn't ask that very carefully, so that's partly my fault. So I'm trying to show you how I know how to write this inequality. It's just the normal start, and the normal period ends at 2 pi. So what do? How do you solve this?
You make it equal.
Well, I did, and then you just subtract pi. So in this case, I gave you one that's actually sort of nice. So you just get a negative pi is less than or equal to x is less than or equal to pi. So the negative pi is my starting x, okay? And pi would be where I end with my x's. Are you guys okay with that? Okay, and I'm going to put the table below here. Yeah, I'm going to put the table on. Oh, I can't do that. I guess I'll have to squeeze my table in here. You guys have a little bit more room, I think. So I can get my table in here, and I just have to give myself room to graph. So we're going to start this thing at a negative pi, and then in 1, 2, 3, in 4 steps, I need to end up at pi. And that you find that by finding the period and your count bys, right? So the normal period is 2 pi. The number in front of this x is still 1, isn't it? So this period still is 2 pi. Find your count bys by multiplying by 1/4. So we are going to count by pi over 2 zeros. So that's normal. That's what we would usually see in a sign of x. So we're going to count by that. So a negative pi plus pi over 2. So how comfortable are you guys with your fractions? Because the first one will be, I need to start at a negative pi and I need to add pi over 2. So how do you do that? Well, put this into pi over 2 terms. So what is a negative pi if I wrote it as a negative something pi over 2? I need a negative 2 there. Does that make sense? Now you can add. So what's a negative 2 plus 1?
Negative 1.
And a negative 1 plus 1 is?
0.
And 0 plus 1 is?
1.
So there is your sequence. Start with a negative pi, negative pi over 2, 0, pi over 2, and pi. Okay, what's the next thing? So let's see, I found the period, I found the compacts, I'm done with the top line. So your next line is what? I'm telling you right here. This is the one line that should be in every graph that you do for me, right? Every table, when you do a graph, every table should include that. So that goes with this. It goes with x plus pi over 2. Sorry, with the sign of x plus pi. Start at 0, next one's 1, 0, negative 1, and 0. So what else do I need to do? Anybody? I don't want to do that yet, but yes, I do need to shift down. What do you want to do? What do you need to do first? The 2. Yeah, we need to do 2 times this mess, okay? You do 2 times 0, which is still? 2 times 1 is? Okay, so then you get 0, negative 2, and 0. And then the last shift is the up or down. So it is down, so that would be the negative 1. So now a negative 1 plus 2 sine of x plus pi. So this is why I need a little more space, but so the negative 1 just subtracts from this, right? So I guess my graph is going to start at a negative pi, at a negative 1, then it's going to go up to 1, back down to a negative 1, down to a negative 3, up to a negative 1. Is everybody okay with that? Yeah. Alright. Pick one more color for that. I guess we're doing purple. So negative 3 is the lowest I need to go. So I'm going to put a little bit more room at the bottom. But I also needed to make sure I start this at a negative pi. So if that's a negative pi, then that would be negative pi over 2, that would be 0, that would be pi over 2, and then this would be pi, right? So notice that I'm not going to label every single thing on the x-axis, because I think it ends up getting in the way. So at a negative pi I need to be at a negative 1. At pi over 2 you're at 1. Then I'm back down at negative 1 at 0. After that I need to go down to a negative 3, and then I come up back to 1, or sorry, negative 1. So the actual graph is going to look like this. Okay, and that's good enough.